Welcome to the lesson on chain rule. The objective for this lesson is to find derivatives of composite functions. For instance, m of x equal to x squared plus 4 quantity cube is an example of a composite function. This function is a combination of a quadratic function and a cubic function. As you could see, the outer function, that's f of u, we could think of f of u, the outer function, as u cubed, where your u, this u here, is the function x squared plus 4. We can express the function here as a composition of the function f and g. So this m of x is just f circle g, where our inner function g of x is this quadratic function x squared plus 4, and the outer function f is u cubed. Now in this lesson, we will learn to differentiate such functions. First, let us extend the power rule. If you recall, the power rule is x, the derivative of x to the n with respect to x, and this is equal to n x to the n minus 1. And to generalize it, we will think of this x here to be u, where u is some differentiable function in terms of x. So for instance, if you have the function f of x or y equal to f of x, which is equal to u to the x to the n, so if you have a function u to the x to the n, the derivative of this function using power rule is just n. So you bring down the exponent here, so you have n, and then copy the base, u of x, and then subtract 1 from the exponent, times the derivative of the function here. Now to simplify the notation, the general power rule, if you have u of x as your base, is equal to n u to the n minus 1 times the derivative of u. To illustrate this, let us consider the following functions and differentiate them using the general power rule. Let's recall the general power rule. Now the formula for differentiating u to the n, where u is some function in x, and differentiating this with respect to x, is equal to n, you bring down the power here, so we have n, times u to the n minus 1, subtract 1 from the exponent, times the derivative of the base, the derivative of u, times u prime of x. Now let's apply that to f of x equal to 3x plus 1 quantity raised to the 4. So to apply the general power rule, we would first think of our u. So if you think of this as your u is equal to 3x plus 1, then f of x will just be of the form u to the 4th. Now the derivative of u to the 4th using the general power rule here is 4. You bring down the exponent, so you have n, and our n here is 4, times u to the n minus 1, so to the 4 minus 1, that is 3, times the derivative of u, so times u prime. So using this formula, the derivative of this function is 4 times, what is our u? 3x plus 1 cube, so copy the power here, times the derivative of u, so times the derivative of 3x plus 1. Derivative of 3x plus 1 is 3, since the derivative of 3x is 3 and the derivative of 1 is 0. So times 3. So therefore, this is the derivative of the given function here. You can then simplify this as 3x plus 1 cube. Next, let's consider this given function here and find the derivative. So to start, let us find our u first. So if we let u be equal to x cubed plus 4, the y here is now of the form u to the 7. And the derivative of u to the 7, y prime, is the derivative of u to the 7 using the general power rule is equal to 7 u to the 6 times the derivative of u. And since our u is equal to x cubed plus 4, we therefore have 7 times x cubed plus 4 to the 6th times the derivative of u, the derivative of x cubed plus 4. Differentiating this, we have 3x squared plus the derivative of 4 is 0. So when doing your homework, you can write your answer like this. This will be sufficient. Or you can further simplify this into just multiply, combine similar terms, multiply the constants. You have 21x squared times x cubed plus 4 to the 6th. Now for the third function here, if we are to differentiate this with respect to the variable t, we can use the general power rule if we rewrite this expression here. So notice if we let u be equal to t squared plus t plus 4, then this expression here will just become 1 over u cubed, which you can write as u to the negative 3. And the derivative of u to the negative 3 with respect to t using the general power rule is just equal to negative 3 u to the negative 3 minus 1. I'll just write that down. Negative 3 minus 1, and that is equal to negative 4, times the derivative of u, so times u prime. So this means you have negative 3 u to the negative 4 times u prime. Now, our u is equal to t squared plus t plus 4. So therefore, we have negative 3 times t squared plus t plus 4 raised to negative 4 times the derivative of u, so times the derivative of this. So let me just write that down again. Times the derivative of t squared plus t plus 4 prime. So this is just equal to negative 3 times t t squared plus t plus 4 raised to negative 4 times 2t plus 1. 2t plus 1 is the derivative of t squared plus t plus 4. And then again, you can input your answer like this when you are doing your homework. Now for this example, we have m of x equal to cube root of 8x minus 3, and we want to find the derivative of m with respect to x using the general power rule. So to do this, we will first think of our u. U here will be the expression inside the radical sign. So u is 8x minus 3. Now, m of x will be of the form cube root of u. Now, you can also write cube root of u in exponential form as u to the 1/3. If you recall, the nth root of x to the m is equal to x to the m over n. Now in this case, our m, the exponent inside the radical sign, is 1. That's why our numerator here is 1. And the index here is n, and that is the denominator. So therefore we have 3 in our denominator here. Now that we have written m in exponential form, then we can use now the general power rule to differentiate m. So using this, we have m prime equal to 1/3. So you bring down the power, 1/3, copy u, subtract 1 from 1/3. So 1/3 minus 1 is negative 2/3 times the derivative of u. So times u prime. Now let's substitute u here. We have 1/3 u. Our u is 8x minus 3 raised to negative 2/3 times u prime. So this is equal to 1/3 8x minus 3 negative 2/3 times the derivative of 8x minus 3 is 8. So you can write your answer, input your answer like this in MyMathLab, or you could also input it like 8 over 3 times 8x minus 3 to the negative 2/3. Now for letter B, here we will think of u as 2x cubed plus 4. So therefore, this expression here is just equal to u to the negative 5. Then we can differentiate now m. So the derivative of m is equal to, using the general power rule, is negative 5 u to the negative 5 minus 1 times u prime. And that is equal to negative 5. Then what is your u? U is 2x cubed plus 4. And then negative 5 minus 1 is negative 6 times the derivative of u. So 2x cubed plus 4 prime. And that is equal to negative 5. 2x cubed plus 4 to the negative 6 times the derivative here is equal to, you bring down 3, so you multiply 3 by 2, so that is 6. And you subtract 1 from the exponent here. So you have x, 3 minus 1 is 2. And the derivative of 4 is 0. This is the derivative of quantity 2x cubed plus 4 to the negative 5. Now for the third function here, we will also express this in terms of u. Our u in this case is 15x squared plus 1. Therefore, m is the square root of u. Then write this in exponential form. This is equal to u to the 1/2 using the formula here. Then we can differentiate m. So m prime is equal to, you bring down 1/2. So you have 1/2 u to the, subtract 1 from 1/2, 1/2 minus 1 times the derivative of u. So m prime, therefore, is equal to 1/2 u to the negative 1/2. 1/2 minus 1 is negative 1/2 times the derivative of u. And then let's plug in u. So u here is 15x squared plus 1 to the negative 1/2 times the derivative of 15x squared plus 1. This is equal to 1/2 15x squared plus 1 to the negative 1/2 times the derivative of 15x squared, which is 30x, and the derivative of 1 is 0. You plug in your answer for m prime like this.